Good morning, students. Today we will discuss about applications of dipole moment, part 2. So already few applications are discussed before. Now we are going to discuss about applications of dipole moment 2. So applications of dipole moment 2 means, so this is also other applications. Already we have discussed some few applications are covered before class. So just we are discussing about some properties also. So NH3 has higher dipole moment than NF3. So this is NH3 has higher dipole moment than NF3. Why? Here this is question. NH3 has higher dipole moment. When you observe the structure of NH3, so this is the structure of NH3. So here next we will compare with NCl3 also we have compared. NCl3 also we have compared. And NF3 here this is nitrogen trifluoride. So here the bond moment is in this direction. So here also the bond moment in same direction like this. So therefore in these two cases bond moment in same direction, but in case of NF3, here bond moment is there in this direction, in this direction. So this bond moment and this bond moment, two bond moments get cancelled. Resultant bond moment is the sum of these two bonds only. Therefore here 4 bond moments are there. 4. This is 1, 2, 3, 4. For example, this is +1, +1, +1, +1. Total +4 bond moment. Example I am giving. Here also same. But here this is +1. This is +1, +1, +1. Here -1. This will cancel. How much we get? +2 only. Resultant bond moment is +2. That means it has less bond moment than NH3. So NH3 and NCl3 because so actually dipole moment is a vector quantity. So therefore bond moment vector quantity means it is the sum of the all vectors. So here when you compare these three, so it has more. These two are having more when compared to NF3 because the bond moment in the same direction in case of NCl3 and NH3. So this is also important. One of the application. So by knowing this one, we can confirm the molecules also. So molecules which having more dipole moment, having more polarity. So that is also one of the important thing. After that, second one is cis and trans isomers. Cis and trans isomers also separated. For example, cis isomer and trans isomer, I will explain here. Cis isomer and trans isomer. Cis isomer and trans isomer. This is cis isomer. This is trans isomer. So here bond movement is in this direction, in this direction, in this direction, in this direction. Therefore, bond movement is not equal to 0 in case of cis isomer. But in case of trans isomer, here in this direction, in this direction, in this direction, in this direction. So here, sorry, in this direction. So two are, this is and this is get cancelled. This is get cancelled. So in this direction is also there, in this direction is also there. Therefore, mu equal to 0 for trans isomer. So for same direction, in this same direction, bond movement is in same direction. So bond direction is in opposite direction. So opposite direction, both will get cancelled here in case of. So what is the use of this dipole moment? Means we are, by knowing cis isomers are having more polarity, by knowing these values, means we can confirm that cis isomer having more polarity than trans isomer, that we confirm that. So this is also very important. We know that when cis isomers means identical groups are adjacent to each other. So here identical groups are adjacent to each other. So here identical groups are opposite to each other. Identical groups are opposite to each other. So this is also one of the important. So because of dipole moment, we confirm that so cis isomer having more polarity than trans isomer. In case of trans isomer, opposite directions, identical groups are in opposite direction. Here same direction. So if it is considered as plane, so here same these chlorine atoms are same side of the plane. Here chlorine atoms are opposite sides of the plane. Therefore this is also very important thing to separate cis isomer and trans isomer. After that, just we'll compare the dipole moment of ortho, meta, para isomers. So ortho, meta, para isomers, just we'll compare which one is having more polarity. So I will explain here. So here cis ortho isomer, ortho, meta and para isomer. So ortho dichlorobenzene, meta dichlorobenzene and para dichlorobenzene I will take here. So here this is ortho-dichlorobenzene, this is meta-dichlorobenzene, and it is para-dichlorobenzene. So here, when you observe the values for ortho 2.53 divide, for meta 1.48 divide, but in case of para mu equal to 0. So here in this direction we are observing, net dipole moment is 0. So therefore ortho isomer having more than meta than para. So here, because ortho isomer having the same direction, so therefore when we compare to this one, ortho is greater than, meta is greater than para. So all para isomers are not having the same type of mu. I will take one example. If the same group, here the same groups are there, chlorine, chlorine. So but if you take, so instead of chlorine, we are taking bromine. So bromine means, so bond movement is not cancelled by each other. Bond movement not cancelled by each other. So here bond movement is not cancelled. Therefore mu is not equal to 0 in case of chloro bromo benzene. 1 chloro 4 bromo benzene, it has dipole moment. So like this we can confirm the which one having polarity more, which one having polarity less. By the dipole moment we can identify. So therefore in case of ortho meta para isomer, ortho isomer having more dipole moment than meta and para. So in case of para, bond moment is cancelled by each other. Net dipole moment is 0. So net dipole moment means in one direction +1, in other direction opposite direction -1. Therefore net dipole moment will cancel by both bond moments. Therefore it is also one of the important. So after that